I'm going to shift slightly. One of the other protective mechanisms are heat shock proteins. And oxidative stress, as I've said, causes aggregation and unfolding, denaturation of protein. They are then broken down. You end up with a non-functional cell, and aging, it results in aging or reduced lifespan. In the presence of the heat shock proteins, these denatured proteins are refolded, and you end up with a normally functioning cell with a maximum lifespan. A slight problem is that in that process you get altered heat shock protein as well. That is viewed as foreign by the body, and you get an antibody response to it. And that is potentially harmful for a reason I explain later. This is a really pretty slide, but I'm not sure it's very easy to understand. But this basically is a coronary artery, and these brown areas here represent macrophages with expressing heat shock proteins. And what you have here is instead of trying to double stain these, so this green area represents macrophages, and the areas which are also sort of staining yellow are those areas which are heat shock protein rich. So what this says is that heat shock proteins are expressed in lesions, both in this case in the coronary artery, in this case in the aorta. And they seem to be in areas where macrophages are producing free radicals. And we measured then the levels of heat shock protein in serum in patients who admitted with chest pain. And what you see here, this is the control group, and these are individuals with chest pain who admitted, and this is a few days later. So there seems to be an acute effect of releasing heat shock proteins. Heat shock proteins are present at very high concentrations in the myocardium. And what we're proposing is that the heat shock proteins are released during that